Today we're going to look at two sample proportion tests, and here is our test statistic. Z is equal to the number of successes of the first group divided by the sample size of the first group minus the number of successes of the second group divided by the sample size of the second group, and that's all over the square root of p hat times the quantity 1 minus p hat times the quantity of the sample size of the first group plus the sample size of the second group divided by the product of the two sample sizes. Now, we don't need this formula unless we're going to do it by hand, but we're going to use StatCrunch for all of our problems today, so we can avoid using this formula completely. And here is the formula for the confidence interval if you choose to do it by hand. But for today's lecture, we're going to use StatCrunch. And it's going to save us a lot of time instead of using this formula. There are some assumptions that we need to make. We have to show that n p hat times quantity 1 minus p hat is greater than or equal to 10 for both of the samples. In condition 2, we have to show that the population size is greater than 20 times that of the sample size. And then we're going to write a sentence about our assumption. Let's let the vitamin C group be group 1 and the placebo group be group 2. So we'll have to check the condition. The first condition is to show that n p hat times quantity 1 minus p hat is at least 10. And we'll have to do it for both of the samples. So let's look at the p hat of the first group. That's going to be the number of successes of the first group divided by the sample size of the first group. So in this case, the vitamin C group, 17 people caught a cold out of 139 people. So that is 17 over 139. And this simplifies to 0.1223. And now we can plug it into the formula. So we have 139, which is the sample size, times 0.1223 times the quantity 1 minus 0.1223, and this equals 14.9. That's clearly greater than or equal to 10, so the first condition is met for the first group. Now we'll check the condition for the second group. P hat for the second group is still x over n, the number of successes divided by the sample size. In this case, we have 31 people caught a cold out of 140 skiers. So that's 31 out of 140. And that simplifies to 0.2214. And then we'll check the formula. Let's plug in 140 times 0.2214 times the quantity 1 minus 0.2214. And this gives us 24.1, and that's clearly greater than or equal to 10. So the first condition is met for both of the samples. Condition 2, I'm going to take the sample size and multiply it by 20 for both of the groups. So for the first group, the vitamin C group, we have 139. We're going to multiply that by 20. And for the second group, we have 140. And we're going to multiply that by 20. 139 times 20 is 2780, and 140 times 20 is 2800. So for the first group, our population size has to be at least 2780, and our population size has to be at least 2800 based on the second group. So we're going to go with the bigger number, and I'm going to say we can assume our population size is at least 2800. And that's it for condition 2. We just have to make the assumption that our population size is at least 2780 and 2800. So we'll just go with the bigger number, 2800. Since all of the conditions are met, let's try the problem. The claim and the complement. We are testing the claim that vitamin C helps prevent colds. I'm testing the claim about proportions, so I'm going to put P1 and P2. We're saying vitamin C helps prevent colds, so I'm going to use the less than symbol. Those in group 1 will get sick less often than those in group 2 who do not take vitamin C. That is the claim. The complement is the opposite of the claim, so P1 is greater than or equal to P2. And now we can do step 1, the null hypothesis, which is always the one with the equal sign. P1 is greater than or equal to P2. And the alternative hypothesis is P1 is less than P2. Step 2, our favorite step. Alpha is equal to 0.05, and that's given here in the problem. Step 3 and 4, we'll go to StatCrunch. Let's try the problem now on StatCrunch. We'll go to Stat, Proportion Stats, to Sample with Summary. The number of successes of the first group is 17. 17 people got a cold out of 139. For group 2, 31 people caught a cold out of 140. We're going to go to hypothesis tests, and the null hypothesis is always set on equals for your homework and StatCrunch. But for the alternative hypothesis, we're going to change it to less than, and the notation's a little bit different than what we did, but it means the same thing. So let's put compute, and our z statistic is negative 2.193, and our p-value is 0.0141. The z statistic from StatCrunch is negative 2.19. The p-value from StatCrunch is equal to 0.0141. Now in step 5, I'm going to ask the same question I always ask. Is the p-value less than alpha? Is the p-value less than alpha? Is 0.0141 less than 0.05? Yes, the p-value is less than alpha, so we do reject the null hypothesis. We do reject the null hypothesis. There is enough evidence to conclude that vitamin C helps prevent colds. Since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude that vitamin C helps prevent colds. Now let's construct a 95% confidence interval for the difference in the proportions. For that, we'll go to StatCrunch. Let's construct a confidence interval. I'm going to go to Stat, Proportion Stats, to Sample with Summary, and we'll put the number of successes, 17, the number of observations for the first group, 139. For the second group, we have 31 successes out of 140. We'll scroll down to confidence interval, and we want a 95% confidence interval, so we'll click this option and we'll press compute. And so the lower limit is negative 0.187 and the upper limit is negative 0.011. From StatCrunch, we have the lower limit is negative 0.187 and the upper limit is negative 0.011. Now I'm going to ask the question, is there a 0 in the interval? Is there a 0 in the interval? Since both of these numbers are negative, no, there is no 0 in the interval. So that implies there is a difference. There is a difference. Since both of these numbers are negative, and group 1 is the vitamin C group, that implies that you're less likely to catch a cold if you take vitamin C. By how much is the question. So we're going to write, we are 95% confident that those on vitamin C are less likely to catch a cold by between, and we'll convert these to percentages. The first one is equivalent to 1.1%, and the second one is equivalent to 18.7%. Now, we never use negatives in real life because the phrase less than implies that these numbers are negative. So we are 95% confident that those on vitamin C are less likely to catch a cold by between 1.1% and 18.7%. Example 2. John Hopkins researchers conducted a study of pregnant IBM employees. Among the 60 employees who worked with glycol ethers, 20 had miscarriages, but among 750 who were not exposed to glycol ethers, 120 had miscarriages. Using StatCrunch at the 0.01 level of significance, test the claim that the miscarriage rate is greater for women exposed to glycol ethers. Construct a 99% confidence interval for the difference in the miscarriage rate between the two groups. We will start by checking the first condition. We have to show that np hat times 1 minus p hat is greater than or equal to 10 for both of the samples. So let's let those that are exposed be group 1. So the first group is those exposed to this chemical glycol ethers. So we'll check the condition for the first group. P1 hat is equal to x over n, and in the first group we have 20 out of 60, so it is 20 over 60, and that reduces to 0.3333. And I'm going to plug in everything into the formula here. So n is 60 times 0.3333 times the quantity 1 minus 0.3333, and that is equal to 13.3, and that's clearly greater than or equal to 10. So the first condition is met for the first group. For the second group, we'll check x over n, the number of successes over the sample size. And in this case, we have 120 out of 750. So 120 out of 750, and that reduces to 0.16. So we can plug it into the formula now. The sample size is 750. 0.16 times 1 minus 0.16, and this gives us 100.8, and that's clearly greater than or equal to 10, so the first condition is met. Now the second condition. We're going to take the sample size of each group and we'll multiply it by 20. So the first group has 60 employees, we'll take 60 and multiply it by 20. And the second group has 750 people and we'll multiply that by 20. 60 times 20 is 1,200. And 750 times 20 is 15,000. Condition 2, we're going to assume our population size is at least 1,200 and 15,000 respectively. Since all of the conditions are met, we can now try the problem. Let's look at the claim and the complement. The claim is that the miscarriage rate is greater for women exposed to glycol ethers. Remember, group 1 was those exposed, so we'll say P1 is greater than P2, and the complement is P1 is less than or equal to P2, which is the opposite of the claim. Step 1 is the null hypothesis and the alternative hypothesis. The null hypothesis always has the equal symbol, so in this case it's the complement. And the alternative hypothesis is P1 is greater than P2. In step 2, we'll just state alpha, and alpha is 0.01. Step 3 and 4, we'll go to StatCrunch for those. Let's try the problem on StatCrunch. We're going to go to Stat, Proportion Stats, to Sample with Summary. For those that are exposed, we have 20 out of 60. And for those that are not exposed, we have 120 for the number of successes over 750 observations. We'll perform a hypothesis test, and the null hypothesis is always set as equals for your homework. But for the alternative hypothesis, we're going to change this to greater than. Let's press compute. And our Z statistic is 3.42, and our p-value is 0.0003. From StatCrunch, the Z statistic is equal to 3.417, and our p-value is equal to 0.0003. And of course, in step 5, we always ask the same question: is the p-value less than alpha? Is 0.0003 less than 0.01? Yes, it is. Now we can finish step 5. In step 5, we know that the p-value is less than alpha, so we do reject the null hypothesis. We do reject the null hypothesis. There is enough evidence. There is enough evidence to conclude. And remember, our conclusion is always in terms of HA. And if you look at HA, it says there is enough evidence to conclude the proportion of those exposed have a higher miscarriage rate. Since the p-value is less than alpha, we do reject the null hypothesis. There is enough evidence to conclude that the proportion of those exposed have a higher miscarriage rate. Now we will try a 99% confidence interval for the miscarriage rate. And for that, we'll go to StatCrunch. Let's look at a 99% confidence interval now. We'll go to Stats, Proportion Stats, to Sample with Summary. And we'll enter the number of successes. There were 20 out of 60 for the first group, and for the second group we have 120 out of 750. We want to click the confidence interval option, and we'll change this to 99% or 0.99. Press compute, and here is our lower limit 0.013 and our upper limit 0.334. From StatCrunch, we have the lower limit is 0.013 and the upper limit is 0.334. And then I'm going to ask myself the question again, is there a 0 in the interval? And since both of these numbers are positive, the answer is no. And that implies there is a difference. There is a difference. And since group 1 is the group that has the exposure to glycol ether, then we're going to say that they have a higher rate. By how much? So let's convert these to percentages. We are 99% confident that those exposed have a higher rate of miscarriage by between 1.3% and 33.4%. We are 99% confident that those exposed have a higher rate of miscarriage by between 1.3% and 33.4%.